Here's the second part of periodic functions. We're just going to do a little bit more of the same as the first example that we did. So here we have f of x. It's a periodic function. We know it's periodic because it has a dot, 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 so there's some type of pattern that continues. And so we're going to work kind of through the same thing. So we're going to graph it, then we're going to give the period, domain, and range, and we're going to write the equation in simpler form. So let's go ahead and graph this. So f of x equals -1 between 0 and 3. So on our graph, between 0 and 3, we want our graph to be -1. So -1, I'm going to put a circle on each side of that. So at 0 and 3, I want to look at to see what I want to do with that circle. Looks like on the left side, I want to leave the circle open, and on the right side, the circle should be closed. All right, moving on to the next section, the next piece, we want f of x to equal 1, and we want that to equal 1 from 3 to 5. So from 3 to 5, it's going to be 1. So let's put in our values here. So this is 1, 2, 3, 4, 5, 6. All right. So we'll label that. Next, we have the graph is equal to 2. The graph is equal to 2 from 5 to 6. Actually, I need to go back and jump ahead a little too much because we want, at 5, we want this to be a closed circle. Now we can go ahead and graph 2 from 5 to 6. So that's just a small segment from 5 to 6. We're going to be at 2. I'm going to put a circle at 2, at the 5 and 6. And looks like I leave it open at 5 and close the circle at 6. And then we're back to -1. Let's just graph these. This, by looking at our first one, it should be 3 units long, and it is. It's from 6 to 9. So from 6 to 9, I'm back at -1. Circle on each end. On the left side, it should be open, and the right side should be closed. Then we should be at x equals 1. So 1, and that's from 9 to 11. 9 to 11. Put the circles there. Again, left is open and right is closed. And then our last one we'll do red again. That's going to be up at 2, and that's just for 1 unit from 11 to 12. Left is open and right is closed. And so we can see a pattern emerges there. With knowing that pattern, we can kind of move backwards to the left side of 0. So we should have 2 from -1 to 0, and then so we'll put in just one more section here so we can see this, and that one was 3 units. So there we go. So there's a graph of it. We could actually keep graphing further, but there it is. You don't have to do it in different colors. Part 2 here says, give the period, domain, and range. Well, looking here, I like to start around 0. So here's x equals 0. We have blue, green, red, and back to blue. Now, I know it's not always color-coded, but we can see it a little bit better there. So there's our period. So our period is 6. So the period is 6. The domain. Well, if this pattern continues, all real numbers are accounted for here because the open circles are accounted for by these closed circles. So the domain is all real numbers. The range, we only get 3 values for the range. We get -1, 1, and 2. So that is the range. Find f of 20 and f of -8. So f of 20, That is not on our graph, so we kind of have to extrapolate there. We have to figure out what will 20 be like. So from 0 to 6, from 6 to 12 is going to be a section. So from 12 to 18 will be a section. So 6 units there, 6 units there, 12 to 18. And then, so this is going to be 18 here. We're just kind of writing and thinking. And then our next section would go up to 24. So 20 is right in here. That's where x equals 20 would be. Well, what does that correspond to? We always, these dotted lines are kind of restarts here. And so at 20, that's 2 units from our starting spot. So 2 units from our starting spot, looking at this starting spot, 2 units. So 20 would match up with 2. And so what does f of 2 equal? F of 2 was -1. So f of 20 will equal -1. So f of 20 equals -1. We can continue this idea backwards. Here's another 6. So that brings us to -6. So -7 and -8. There's -8. That will correspond. We can pick really any of these starting things here, and we want to be to the left 2. So left 2, well, that's going to be, notice here, there's left 2, that is negative or positive 1. So f of 8, the f of -8 is going to be positive 1. All right, it says write this in a simpler form. All right, so let's think back to what we mentioned before. We want to find the period, which we found the period. And so with that, we're going to use this idea of 6k, where k is an integer. K is an element of the integers, which I did not write that on the first video. I should have. And so we want to write f of x we want to look at what includes 0. So we're going to actually look at, I want to box in this thing right here. Here's what we're going to look at, which corresponds, let me erase a lot of my stuff up here, which corresponds to these first 3. So our 6k is going to represent that 0, because 6 times 0 is not because this is 0, but we want this 6k to equal 0. And then to get to 3, to get from 0 to 3, we add 3. So we're going to take that 6k and add 3. And so that's going to be our idea, where this function equals -1 if 6k, or x is between 6k and 6k plus 3. But we have to make sure the inequality signs are right. And actually, I forgot an inequality sign, so we'll fix that. And that's a less than or equal to 6k plus 3. Then our graph was equal to 1. That is right here. That was from 3 to 5. Well, we're not using 3, we're using the 6k. So 6k represents kind of our 0. How do we get to 3? We add 3 to 0, so 6k plus 3, which is less than x, which is, the right side is filled in, so it's going to be less than or equal to. And we need to go up to 5, so we have 6k plus 5. And then the function could equal, or does equal 2. For that last little interval, it's only 1 unit long from 5 to 6. So this is going to be 6k plus 5 from is less than x, which is less than or equal to the 6k. And how do we get to 6? Well, 6k plus 6. And maybe we should put this out here where k is an integer. I'm going to circle back here to these this question here, question 3. A way to think about this positive anyway, we could take 20, or f of 20, and this is also because this is starting at 0, but 20, the period is 6, so 20 divided by 6. So that means we had 3 full rotations. 6 times 3 is 18, and we had a remainder of 2. So that remainder there is what we looked for when we were doing that, finding f of 20. All right, moving on to another one. We're going to graph it and then see if it's periodic. We're going to give the domain and range and period. The fact that it's asking us for the period makes me think it is going to be periodic. So we want our graph to equal 0 between 0 and 2. So we want our graph to equal 0 from 0 to 2. Figure out what we need to do with our circles. Looks like the left is open and the right is closed. Next, we'll go to 1, from 2 to 4. Okay, let's label our graph. This is 0, 1, 2, 3. We want it to be 1 from 2 to 4. So from 2 to 4, it's 1. Looking at our inequalities, left is open, right is closed. It's 2 from 4 to 5. So we're just going from 4 to 5. Once again, the left is open and the right is closed because of the inequalities. It's asking if it's periodic, so let's keep graphing. We're at 0 again. 0 for 2 units from 5 to 7. Left is open, right is closed. And then 1 from 7 to 9. So from 7 to 9. Left is open, right is closed because of the inequality signs. And from 9 to 10, it's 2. And it is periodic. So the domain, once again, the domain is our real numbers. The range is only 3 values in this case. It's 0, 1, and 2. And then the period. The period, in this case, is 5. So the period is 5. All right, we need to find g of 17, g of the square root of 899.4, and g of 729.58. These are actually all in the positive, so we might want to evaluate or at least think about that a little bit to find these. So g of 17. G of 17. Well, these repeat every 5. So 17, so 15 is going to be there. 17 is going to be 2 away. Should be, here's 15. And then 17, 16, 17. Here's 17. It's 2 away from kind of a new starting point there, which 2 away from our start, 1, 2, the value is 0. a way to think about this is 17 is 5, and I'm thinking 5 because the period is 5. 5 times 3 plus 2. So the fact that we have a 5 times 3, that means we've just gone 3 periods, and we're starting again. So the plus 2, we can look at 2 on our first period that we look at from 0 to 5 and see that when x is 2, the y value is 0. So g of 17 is 0. Square root of 899. This is just going to be just shy of 30, because 30 times 30 is 900. So this is going to be like 29.9 something. So where's 29.9 something going to fit? So g of the square root of 899.4. Well, that is going to be 5. So 29.99, or not 999, but 29.9 something. Maybe I should put approximately equal to 29.9. 29.9 divided by 5 is 5 with a remainder of 4.9. So we're going to put 5. 5 times 5 is 25 plus 4.9-ish. Well, that's 5 periods, so we're just looking at where does 4.9, what's that 4.9? So when we looking back up at our graph, 4.9 is about here. So what's the y value at 4.9? The y value is 2. And then g of 729.58. Well, just thinking through this one, 5 goes into 100 20 times. So going to 100, we would really just be looking at something that looks like this section. Well, if we go 107 times, we're at 700. So really, we're very similar to this, the one before it, because we don't have to worry about the 7 in this case, the 700, because that's like starting over. So again, it's almost like 29.58. So we're going to be looking at g of 4.58, which from the one we just looked at, we know that in the 4s, 4.58, which is about right here up on our graph, still is paired with 2. So that's equal to 2. All right, we want to simplify the function rule for g of x. So g of x is either, we're going to look at our starting point here at 0. It doesn't always start at 0. Some of those can be a little bit trickier if they don't, but this one does. So this starts at 0. X equals 0. When x equals 0, y was 0. And our period is 5, so we're going to think 5k is going to go, so if 5k is less than x, which is less than or equal to, and we are looking at from 0 to 2, so how do we get from 0 to 2? We add 2. So how do we get from 5k, 2 away from that? We do 5k plus 2. And then our next value is 1. Well, 1 we noticed was from 2 to 4. Well, how do we get to 2 from 5k? That's, again, 5k plus 2, which is less than x. Well, how do we get from 5k to 4? Or 4 away from 5k, we add 4. And then it was equal to the value of 2 if, so it was from 5k, so it's from 4, so we're going to do the 5k plus 4 is less than x, which is less than or equal to, how do we get to 5? 5 units from 5k, well, we'll do 5k plus 5. And that is the function in a simpler form.